Okay, so let's start our class. What we are going to do today, we'll see some examples from chapter 2. Before we go to chapter 3, let's revise chapter 2 using examples. So we'll see different examples from chapter 2 today. So let's start from system property, discrete time system properties. So first we'll see what's linear, nonlinear, discrete time system. We'll see what example 1. Example 2, time invariant and time variant. Example 3, we are going to see convolution sum. Okay. And example 4 will be from difference equation. So we'll see different examples today. Okay, so let's start our first example. We are asked to identify whether this system is linear or non-linear. Okay. Okay. So this system is a discrete time system with input x of n, input signal, and the system represented by capital H. We'll come to that in chapter 3, why it's H. So this is a discrete time system. After processing the input signal, it generates new output y of n. This is what a discrete time system. So the system is a squaring device. This system is what we call it a squaring device. What's a squaring device? Whatever input you apply, the output will be the square of the input. As you can see from this equation, if you apply any input, the output will be the square of the input. Very simple system. If you apply any input, the output will be the square. So let's see whether this system is linear or non-linear. So when you say a system, it takes inputs, right? And after processing, it generates output. That's what we call it a system. It can be small system, it can be big, complicated system. But how we define a system? It takes some type of input, and it generates the another signal, what we call it a response. For example, if you take the input as the gas pedal of your car, when you drive, there is a gas pedal, so which represented by this pressure input. Now the system is our car here, right? So when you press the gas pedal, we are increasing what? We are increasing the pressure, right, as a function of time. signal, input signal, mostly it is called cause, right? It's called cause. So in signal system we call it cause and effect. So this car is a system, connection of different mechanical, electrical systems. So when it takes input, gas pedal, when you drive a car, when you press gas pedal, what will be the response of the system? Velocity, speed of the car increases, right? Velocity, speed as a function of time. So you see, this is how signal and systems are related. Okay, a system, it takes some inputs, process it, it generates some output. So car is one big system. It takes inputs, generates. For example, if you take MP3 player, or a stereo, So here you connect what? Your flash disk or CD, flash or CD. It generates what? It generates sound, right? So when you play your flash, if some audio file, this MP3 player or a stereo device, it will give you what is the input, what type of input the CD or your flash stores. 0 and 1, digital. This MP3 player generates what type of output? Sound, which is analog. Analog output. After processing this stored binary data in the flash or the CD, it generates, it plays the sound. How about the car? Both input outputs are in analog form. Pressure from the gas pedal. When you give some input, the car increases speed. When you press, when you release the pressure, when pressure decreases, the car speed decreases. So with systems, as you can see here, different types. They take different type of inputs. After processing, they generate different type of response. So the input mostly called what? Cause. The output is called effect. In engineering, we call it cause and effect. Okay, so as I said, systems can be continuous time, it can be discrete time, the input signal can be digital, output can be analog. So that's how we define signal systems. In discrete case, for example, in this system, a squaring device, so whatever input you apply, the output will be the square of the input. So here we are asked to determine whether the system is linear or not. Okay, so let's check superposition. Remember, to check whether a system is linear or not, we have to check superposition and homogeneity. So in this case, if you apply the first input x1n as input, what will be the output? Let's call y1 of n. What is y1 of n? This is a squaring device. So whatever input you apply, it is a square. So x1 square of n. This is the first output when you apply x1n. Now when you apply the same system, squaring device, when you let's apply another input, x2n. So what will be the output? The output will be another y2n, okay, y2n, which is equal to, what is the input? X2. So it will be x2 square. This is second output. Now to check superposition, what we have to do is add the two signals and apply it to the system. This is our system squaring device. So what will be the summation of the two inputs? X1 n plus X2 n. Okay, so this is when the two signals are added together, superposition. What will be the response of this system? Whatever input you applied, the output will be the square. So let's call this output Y3. Y3n. Y3n means what? Square of this. What is the input? X1n plus X2n. This is the input applied as a summation. So we have to make the whole square, right? We have to make the whole square because it is a squaring device. Whatever input you apply, it is a square. So what is the square of these two summations? It will be what? X1 square of n plus X2 square plus 2 times X1n X2n, right? Which means if you have two numbers, a plus b, the whole square is what? If you make the whole square, it will be a square plus b square plus 2ab. You know this, right? So that's why the square of this is x1 square plus x2 square plus 2 times the multiplication of the two. Now, look here. If you add these two signals together, these two outputs together, this output y1 is the corresponding output for x1. Y2 is corresponding output for x2. Now, if you add the two outputs, y1 of n plus y2n of n. What are these outputs? When you apply the inputs individually, so x1, when you applied, the output will be x1 square. So y1 is what? x1 square, right? x1 square. What is y2? Y2 is here, x2 square. Okay, x2 square. Now, compare the summation of the two outputs with y3. To say a system satisfies superposition principle or linearity, what we have to do, first apply inputs individually to the system. X1, it generates y1, right? It generates y1. When you apply x2, it generates x2. So the two outputs, when you add, it generates this one. This is the summation of the individual outputs, okay? Y1 plus Y2. Now, when you apply the two inputs as a summation, in this case number 3, you see, when you apply add the inputs and give it to the system, it generates Y3. What is Y3? The square of the inputs. We get it here. Now compare the two. In this case, this is x1 square n plus x2n square. But in this case, there is additional term here. Are they equal? No, they are not equal. They are different. So, what the system does not satisfy what? The system does not satisfy superposition. Okay. So the system, our conclusion is, does not satisfy superposition. If the system does not satisfy superposition, it's what's our conclusion? Non-linear system. Okay, the system is non-linear. For a system to be linear, it must satisfy both homogeneity property and superposition. If one of the two does not satisfy, our system is non-linear system. In this case, the system does not satisfy superposition principle. Let's see one more example. What superposition means? Look here. In this case, this system is simple multiplier system. Whatever input you apply is multiplied by 2, right? So it's very simple system. Input, when you apply x1 as input, what will be the output? y1. Y1 will be as you can see from this equation, y is 2 times of the input. So 2 times of the input is x1 of n. Okay. Now apply another input for the system. Let's call this x2 of n. What will be the output? Let's call it y2n. This is the corresponding output when you apply x to the system. So what will be the y2? Again, it is 2 times of the input. Simple multiplier system. Now to check superposition, what we have to do? Apply the summation of the two inputs, x1 plus x2. x1, add the two inputs together and apply to the system x2n. What will be the output? The response. We call it y3n. So the input is the summation. So 2 times, what is the input? Input is now the summation of the two. Okay, x1n plus x2n. This is our input. So the system, our system multiply this input by 2. Now, what does it mean? 2 times x1 plus x2 means you can write 2 times x1n plus 2 times x2n. Okay, now this is the output when we add the superposition of the two inputs. When the two inputs added together and applied to the system, this is our input now. So multiply the whole input by 2. So 2 can be 2 times this plus 2 times this. Now to check superposition, add the two outputs, individual outputs, y of n, y1 of n plus y2 of n. What are these two? The outputs when the inputs are applied individually. What is y3? Output when we add the two inputs and apply together. The signals are applied together at the same time, added together and applied to the system, the output y3. Now, if you add these two individual outputs, what is the first output? 2 times of x1n, right? We get it here. What is the second output, individual output? Plus 2 times x2n. Now, what we have to compare? This to this one and this two. So as you can see here, they are the same. They are equal. these two are equal. What are these two? First one, summation of the two outputs, individual outputs, y1 and y2. y1 is when x1 is applied individually. y2 is when x2 is applied individually. The summation of the two outputs here, we get this one. Third case, apply the two inputs together as input here. We get what? y3. This is our y3. Compare y3 with the summation of y1 and y2. If they are equal, it satisfies superposition principle. So we call the system linear system. Okay. So this system is linear, but the previous one is nonlinear. Why it's nonlinear? Because when you apply the two inputs individually here, x1 it will be x1 square, x2 it will be x2 square. When you add the two outputs in individual outputs, we get this one. Now add these two signals and apply it as one input, we get y3. y3 is this is the square of the input. Input is now x1 plus x2. So if you add two things and the whole square, it will be what? For example, 2 plus 3, the square means what? 2 square plus 3 square plus 2 times 3, right? Can check. So we get this one. So you see, these two terms are different. If they are different, our system is nonlinear system. Okay. Now let's go to example number 2. To check whether a system is time variant and time invariant. Part A is a multiplier. You see this system, whatever input you applied, it's multiplied by 2. We are taking here very simple systems. If you apply x to this system, what will be the response? From this equation, the response is y of n will be 2 times the input. Okay, 2 times of x of n. Now, to check time variance, time invariance, what we have to do, shift the input by some amount. Let's say if you shift this by 2 and apply to the system, what will be the output? The output is, let me call y2. Now input shift, any input applied multiplied by 2. So that will be the output 2 times what is the input? X of n minus 2. So this is output when shifted input is applied. Shifted input is applied. Okay. This one, y2. Input is shifted by some constant, in this case 2. So the output will be this, as you can see here from the equation of the system, any input is multiplied by 2. That is how the system is designed. No other operation. Simple multiplier. Okay. It's simple multiplier system. Is it time variant or invariant? We are checking that. So in order to check time variant or time invariant, shift, apply input x of n, record the output. What is the output? The output is 2 times x of n. Same input, but shifted by some constant, in this case by 2, apply, record the output. Now this output is what? This output is output of the system when the input is shifted. How about this? This is output without shifting the input. Now in this case, shift the output. Shift the output itself. Y of n is output, right? Shift it by 2. What will be the result we get? Where is output? Here. When you shift it by 2, n becomes n minus 2. So where is n? N is here. So 2 times x, wherever there is n is shifted by 2. What is this? This is shifted output. It is what? Shifted output. Okay, so compare here, y2 is when input is shifted, we record the output. Here, without shifting the input, we get output and shift the output. Now compare the two. What is the shifted output? Yn minus 2. Shifted output, after applying the input, shift the output by 2. We get how much? We get 2 times xn minus 2. Okay. This is, we are not shifting the input, we are shifting the output by 2 seconds. Second case, not shift the output, but apply shifted input. What will be the output we get? Y2n. We get how much here? 2 times xn minus 1, n minus 2. Now compare the two. They are what? They are equal, the same. So in this case, we say the system is time invariant. Time invariant. The system does not care where the input starts. Time is not the starting point, or in time of time does not affect the system. The system behavior does not depend on time, right? Time invariant. Let's see another example. In this case, again, to check whether this system is time variant or invariant, look here. First, apply input without shifting. So what will be the output? The output is y of n will be the input from this equation. You can see the input is multiplied by n times x of n. Okay. Now this is when our input is applied. Now, second case, shift your input by 2. The same system. What will be the output? Let me call this y2n. So whatever input you apply, it's multiplied by n. So n times what is the input? Input is x n minus 2. Okay, that is our output. Y2n is our output when shifted input is applied. N times x of n minus 2. Next, shift the output. Okay, when you shift the output by 2, what will be here? When you change n by n minus 2, so this n becomes n minus 2 times x of n minus 2. So what is the shifted output? N minus 2 x of n minus 2. look here. This one is when shifted input is applied. This one is when you shift the output y of n. After applying input, shift the output. In this case, first shift the input, record the output. Are they equal? These two are not equal. They are not equal, right? Because here it is n, here it is n minus 2. So what is the system? System is time variant. Time variant system. Not time invariant, but time variant system. Say type of systems, their behavior, their characteristics depends on time. So some systems can be time variant, like this. This multiplier is a time variant system. This n times x of n system is time variant system. Okay,